Hey everyone, this is Anshul Sadaria, software engineer at Google. In the previous module, we talked about different basics of C++ programming language. We started with a basic structure of C++ code, and we talked about conditional statements, different data types, we talked about variables, and so on. Now, if you have not watched the first module of C++ basics, I would highly recommend you do that first. And before we jump on to the second module, do check out Scalar's free masterclasses taken by industry leading experts only on Scalar's event page. Link is in the description below. Now let's get started with module 2. So this is where we stopped the last time we met in the first module. What did we discuss? We talked about the different data types in C++, how the variables are declared and initialized, what all different operators are there, and then we paused at the conditional statements, which are the if-else conditions and the switch conditions. Now let's take it a notch higher and let's start talking about loops. To the beginners, it might be confusing what loops are, but those who have already understood some of the other programming languages, maybe JavaScript, maybe Java or Python, they know what loops are. But to those who are beginning with C++ as their first programming language, let me just explain what loops are, okay? For example, someone asks you, okay, in the school, I usually used to get this punishment when I used to irritate my teachers a lot, that they used to write in the notebook for 100 times that you will not interrupt the teacher in between the class, okay? And she used to tell me that write this down in your notebook for 100 times. So in programming, obviously you don't need to write out, see out, something, okay? I keep making this mistake with the operator. 1 second. Okay, yeah. So you don't need to write sorry. Let's say the mistake was supposed to be rectified by just saying sorry. Okay. So you don't need to write this particular statement 100 times. For operations where you want to keep on doing a similar kind of a thing for some n number of times, okay, for some number of times, you can use loops. What loops basically mean? There will be a code block. You will start with a code block. You will end at the code block and you will keep on repeating until some condition is getting fulfilled. Okay, so now there are three types of primary loops in C++ programming language. So first one being a while loop. We will talk about the syntax of all of these different types of loops and how you can actually code it. Like we will write the code for that as well. Then a different flavor of while loop is a do while loop. Like I will tell you the difference between both the while loops, like in what situation what should be used. And lastly, there's the for loop. For loop is one of the most basic loops which people usually use in C++. And why it is more widely used as compared to while loops, that I will also let you know. And similar to the if and else statement, there can be nested loops as well. Inside a for loop, there can be a while loop. Inside a while loop, there can be a for loop, and anything can happen. Like any permutation combination is possible. But the first thing to remember is, let's say this is a for code block, okay? This is a code block, and inside a code block, any type of code can be written. There can be an if and else condition, there can be a switch statement, there can be another loop, there can be any other type of code block as well in this, okay? So let's move on to understanding the syntax of while loop first. So this is one of the most basic loops with least amount of syntax, okay? So as you can see on the screen, like the syntax looks like while, and this is a keyword, okay? You cannot use it for variable names. This is a reserved word in C++. While some condition, if you remember in if and else if statements also, we use some type of a condition. So while this condition is fulfilled, we need to execute a code block. Okay, as simple as that. So for example, let's say we have int a is equal to 5. We will keep on continuing with that previous a b example. So let's say int a is equal to 5, okay? And the condition was like while a equal to 5, for example, do something, okay? I don't know, it can be any piece of code. You can do some arithmetic operations, you can print something, you can multiply something, you can add an if and else condition inside this as well. But as long as this condition is true, the code block will keep on repeating itself. Okay, now you might be wondering, I mean, if a in our statement a is equal to 5, and while a equal to 5, we want to keep running the same code block again and again on a loop. So will it not become an infinite loop? You are absolutely right. You need to be very, very cautious about such infinite loops, that your while loop should always have an update statement. Okay, if your condition is using a as a variable or b as a variable, okay, if there are any variables involved in your condition for the while loop, there should be an update statement wherein maybe you are adding something to a. Okay, let's say you are adding incrementing a. So as soon as that condition is violated, you will go outside the while loop, you will exit the while loop. Okay, but this was not one of the best example that I gave. So let's say I want to print hello world for 5 times. Okay, let's move on to code and see how we are going to write it. So in the code also, we stopped in the if and else nested conditions. So let me just get rid of all of that code, and we can write the code for while loops directly. Okay, so what we can do, while, now here we have a equal to 5. Okay, so this helps me keep a count of how many times I actually want the loop to be executed. So what I can say is, while a greater than 0, cout hello world and followed by a new line. Okay, but now if I execute the code as it is, okay, it will keep on running for an endless time. Let's try to execute that as well and show you that how our expected behavior is not intended over here. And this is a very common mistake, to be very honest. If someone writes an infinite loop, you will see it a lot of times that people forget to update the variables in their conditions in order to get the expected return. Okay, let's compile the code. Let's try to execute it. Now you can see this is running endlessly. Okay, I had to press Ctrl C to interrupt the program. Otherwise it would have run endlessly until perhaps this laptop crashes. Okay, so we don't want such a situation to happen because this is not intended. What we wanted was, I wanted to print hello world for 5 times. So what I will do is, I will reduce a by 1 in every loop. So in the first loop, the value of a is 5. In the second loop, it will be 4. Okay, let me just write it in the slides. So loop 1, the value of a is 5. Loop 2, it is 4. Loop 3, it is 3. Loop 4, it is 2. In loop 5, it is 1. Okay, so when we enter the loop for the first time, it is 4. So when we will be entering the loop for the 5th time, it will be equal to 1. Now when we enter the loop for the 6th time, we have decremented it at the end of the loop, if you notice. Okay, so when we will try to enter the loop for the 6th time, the value is 0. And each time we are going to check for the condition, that is a greater than 0. If yes, then only we will move. So for all of these time, that condition was true. Okay, true, true, true for all the first 5 loops. Now as soon as our value is updated to 0, a's value is updated to 0 now, and we try to check the same condition again, this time the condition returns false, and hence we will no longer continue with our while loop and we will exit from it. Okay, now let me just print something at the end of our program, just so that we know that the program executed normally. Normal execution. Okay, so now let's try to compile it and let's see if our expected behavior is seen here or not. If I count properly, these are 5 times. Yes, hello world is printed for 5 times, and then after it exits from the while loop, it is printing normal execution. So this is what we had expected. So while loop is as simple as it looks. Okay, but people usually make this mistake that they go into an infinite loop, or they don't write the condition properly. Okay, for example, if you write while loop something like this, while true, okay, and then there is a code block. Now this condition will be true forever. Okay, this is not going to change. Instead of true, there can be while anything. Okay, this is an interesting thing. I should have told this earlier as well. Let me remove all the other jargon so that I can explain this very properly. Now, when I told you in the if, else if and the while loops, we need to put in some sort of a condition. Okay, while loop, we are putting in some condition, and the code block will be followed only if the condition is true. And same was the case for if and else if conditions as well. But now there are some special type of conditions which are implicitly converted to booleans. For example, if we write while true, okay, now this itself is a boolean. I mean, this is an explicit boolean, which means that it is always going to be true because it's a constant. Okay, if we wrote here instead of while true, this was while false, this would mean that the condition is always false. So it would never enter the while loop at all. Okay, now if I wrote while 1 or anything, okay, any non-zero number, while any non-zero number, any positive number, if I wrote over here, this would also be equivalent to true. Okay, this might not sound so obvious to you, but there are some implicit conversions within C++ wherein an integer can be converted to a boolean. Okay, so now, for example, okay, let me just update the code. You can check in the code what I actually mean. Okay, now in the 7th line, I explicitly write the condition while a greater than 0. But if I remove greater than 0 and if I just keep while a, it will still do the same execution, because as soon as the value of a becomes 0, it converts from true to false, because 0 is mapped to false and all the positive numbers are mapped to true. Okay, so whenever it was 5, 4, 3, 2 and 1, it would implicitly be converted to true. All right. So let's just compile the code again and try to execute it. And this is the same output that we are getting for this changed code as well. Okay, so these are some implicit conversions which you should keep in mind. Like, you can try to reduce the amount of code with such conversions, but for the readability purpose, I would really recommend if you write if a greater than 0, while a greater than 0 only, because then it is easier for the human beings to understand it. Okay, the computer knows, the compiler knows that a and both of these statements, okay, while a is same as while a greater than 0. Okay, both of these mean the same thing over here, but like compiler understands both of those things equally. But for a human being, this is easier to understand because it explicitly tells us that a is an integer and we are comparing it with 0. Okay, so this is just about good coding practices. This is nothing about C++ as a programming language, that you should be as explicit in your intentions as possible. Though both of them are theoretically true, both of them are theoretically same, we should not do that. Now let's talk about do while condition. Okay, now over here one thing is also to be understood, that our code block will only be executed if the condition is true from the very beginning. Now do while loop does something opposite to what while loop does. Now there is before the condition is checked, there is a code block. And like in normal English language also, it's like do, like there can be something over here, there can be some code block, and then check or keep on doing this while some condition is true. Okay, and remember there is a semicolon at the end here which was not there in the while loop. Okay, so now these are two of the significant changes. A semicolon is there at the end of this while condition statement, and a do while loop will always be executed once. Okay, at least once. My bad. Again, poor choice of words. So this will always be, my bad, yeah, be executed at least once. Okay, so when I translate it into English language, it will be like do something, check for the condition, do something, check for the condition. And once when we check for the condition, if that condition comes out to be false, only then we break out of this do while loop. Okay, so now let me try to change the code and let's try to use do while loop instead of a while loop. So this condition will come at the end. So let me just copy paste it to the end and write do in the beginning. So if you notice, this code will also execute for the same number of times, but there is a catch in this. So if you notice, this is the same execution which was previously, but let's say now we update the value. When we initialize it, we update the value of a to be 0 instead of 5. So what will happen is, even though our condition is not getting fulfilled, the do block is before the conditional block, and hence our code will get executed for one time in this situation. So if you notice, hello world is getting printed even though the condition is false, But in the do while loop, this is the classic reason why do while loop can be preferred compared to a while loop. It's because you want to execute the loop at least one time. Okay, so in those situations you can use a do while loop. Otherwise, while loop is like after for loop. I would say in my experience, while loop is one of the most common loops in any programming language. So this was the difference between while loop and do while loop. And obviously in this also remember to update any variable that you are using in your code block. Okay, so in your condition. So if you're using a greater than 0, or if you're using a greater than b, or any other condition that you're checking. Okay, if you're checking for a and b or anything at all. Alright, make sure that there is some update in your code block so that there is a possibility for the condition to break and we exit the while loop. Otherwise, an infinite while loop or a do while loop is very much a possibility if we don't take care of these things while coding. And it is easy to ignore, okay? I mean, I must have written a while loop for n number of times, I don't even remember them in my career. And that is the reason why for loop should be used so that we don't forget the update part. So now this is the major difference between a while or do while loop as compared to a for loop. So this is what the syntax looks like. The for loop, like in while loop, there was just one condition. In for loop, there are three parts. The first one being the initialization. The first part is initialization. The second part is condition, which is common as while loop and do while loop. And the third one is update statement. Okay. And now, see, the condition needs to be only one. Like it can be a true or false related condition. The initialization, it can be any number of initializations that we want to do. It can be one, it can be more than one, it can even be 0. Okay, you can initialize outside the for loop. That is completely fine as well. Update also, it can be 0 or 1 or 2 or any number of updates. Alright, so this can be 0 or more. This needs to be exactly 1. You can add more conditions by having more logical operators like and, or, and so on. Okay, you can use these operators to combine conditions. You can use or as well to combine the conditions. That is completely possible. But ultimately, the condition should end up in some Boolean value. Okay, so now updates can also be 0 or more. So if I were to classically convert the current code, okay, instead of a do while loop, let's say it was a while loop. Okay, let me just retrace it back to the while loop. A is greater than 0 and we'll get rid of this. So now this is the while loop that we wrote. Now if I wanted to write an equivalent for loop for this, I can write something like this. Okay. Now first part should be my initialization, but here a equal to 0. Okay, now this should also be a equal to 5, otherwise it would never have entered. Okay, so a equal to 5. So now it has already been initialized. If you want to re-initialize it or update it to some other value, you can do it over here, or you can keep it empty. Okay, you can put a semicolon and not write anything in front of it to show an empty initialization. You can add the condition same as the one in while loop, and you can also keep the updates empty. Okay, let's copy paste the same code. So you can add the updates inside the code block of a for loop, or you can add the updates in the syntax of for loop itself. Both of them are equivalent. So let me just comment this thing. I think this is for the first time we are using the comment feature in C++. So let me just comment it and try to execute the for loop. This will execute in the exact same way as the while loop. Okay. Now we want to understand what is the beauty of the for loops, why one would prefer it as compared to a while loop. So let me just comment a equal to 5 as well. And over here, I can initialize it on my own with the for loop syntax itself, and I will decrement, provide the updates here as well. Okay. Now let's try to, if you notice, I removed the update statement from the lowermost part of my for loop, and let's try to execute it again. So now if you notice, this for loop is completely equivalent to the while loop that we wrote. We don't have any explicit update statement at the end of the for loop. We don't have any explicit initialization above the for loop as well, like outside the for loop on top of it. We have combined all of that together, and this helps in the brevity of code. Okay, both of them are the same thing. The compiler has the same interpretation of both the codes. So when it's converted into assembly language, if you notice, the compiler converted the normal source code to assembly level code. So whenever it's converted to the assembly level code, it would mean the same thing. The hardware level instructions for both the while loop that we wrote earlier and the for loop that we are writing right now, it would be the same. So let us check how we can add multiple conditions as well. Like this can be b++, and we can have another condition a equal to b. Now sometimes I have seen this common mistake, okay, that sometimes people, instead of putting double equal to sign, they put a single equal to, and a equal to b is an assignment, okay. It will always return 1. This doesn't return a boolean first of all, and since it is an assignment, it always will be equal to true. So this condition will never fail. Let us just try to do that as well. And now let me also initialize int b equal to 0, okay. So now in every for loop, what will be done? A will be decremented from 5 and B will be incremented. Both of these things will happen at the end of the loop. So initially we start with 5 and 0. This is the value of A and this is the value of B. Okay. And this in the first loop, we will enter the loop with these values. In the second loop, we will decrement A and increment B. In the third loop, we will decrement it to 3 and increment it to 2. In the fourth loop, if you notice, we are decrementing it and incrementing B. And now in this process, A and B will never be equal. Okay, you wanted the for loop to be executed till A. Well, first of all, okay, let me take it step by step. Let's first try to see what A equal to B returns. Okay. So my hypothesis over here is that it will always lead to true condition and it will always be executed. So there is a compilation error. So expected unqualified ID before int. I'm not sure what it exactly means over here. Expected semicolon before int. So it says that I should be using a semicolon before int because it's a statement. Okay, did I do something wrong in the code? Apparently, okay. I think this is the equivalent statement. This is what I wanted to do and this should compile, right? Okay, now I try to execute it. First of all, it doesn't enter the loop at all. I think, let me just try with another example where the values of A and B, both of them are equal. Then we'll do some of the changes and then try to see what's the expected behavior. This is also not entering. So my guess is, let's try to print the value of A equal to B. Okay. Let us try to print. Let us first initialize both of them. So in this way, you can initialize both of them in the same statement. Okay. You can just separate them by using commas and you can initialize both of them in the same statement. You don't need to write int A is equal to 0, int B is equal to 0 in separate statements. Now let us try to print this. Let me just put some marker, something, okay. My creativity has ended over here. So I'm just printing something over there. So after something, if you notice, it is printing the value of A equal to B, which is 0. So what I said earlier, that whenever we do some sort of an assignment, this is equivalent to true. I think I said the other way around. This is always equivalent to false. So you were expecting the for loop to be executed, but since you missed out on 1 equal to sign, it translates it to some boolean value, which is always false, and it never enters the for loop at all. Okay. So now let me just change the condition and let me put the appropriate initializations over here. So first of all, let's just not get rid of the initialization that we have done outside the for loop. We can update them as well inside the for loop. Like if we want to have some different starting values of A and B, we can do that in the initialization part. So initially I just declared it, and hence on the declaration, it will automatically assign it to the default value 0. Both of them will have a 0 value, but in the for loop, I am placing an initialization statement that A should be updated to 6, B should be updated to 0, and then we should start it. Okay, so now I have updated it to 6 because I noticed for the value of 5, it was never matching each other. Like both of them were always different. Okay, so I wanted the sum of A and B to be even numbers so that when we decrement one and increment the other, we have a matching condition. So if you notice, hello world is printed 3 times. Okay, so now in the first loop, it will be equal to 6, A will be equal to 6, B will be equal to 0. In the second loop, I think it's only A's value which is getting changed. 4 and 3. So if you notice in the fourth loop, at the end of the third loop, A will be decremented from 4 to 3 and B will be incremented from 2 to 3. So at the end of the third loop, both the values match. And in the beginning of the fourth loop, we check for that condition. Is A not equal to B? So when you check for this condition, okay, 3 not equal to 3, this will return false and we will exit the loop. And hence, our hello world statement is printed only 3 times. So this is the basic way, like this is the most usual way in which we can use a for loop. Updates and initializations are optional. You can place initializations on top of the for loop. You can place updates inside the code block of for loop as well. But it is recommended that since, for loop is given for this specific purpose, that you can put all of them in the same statement. So you should try to adhere to that particular statement as much as possible. Okay. Inside the for loop, you can place some if and else conditions. If you want to place another for loop, that is also completely normal. If you want to, this is a code block and this code block can be anything. It can be if and else statement. You can initialize something inside the for loop as well. You can update the value of any pre-initialized value, okay, pre-initialized variable. You can do anything which is equivalent to a statement. It can contain 0 or more statements. It can be an empty for block as well. If it is an empty for block, it won't do anything at all. All right. So I want you to just try and experiment around with all these 3 different types of loop and check out for yourself how, what works and what not works in all of these 3 different types of loops. Now, from the for loops, let us move on to the non-primitive data types. Okay, arrays is the first non-primitive, first non-trivial part of our C++ module. This is non-trivial. And what are arrays? Okay, this should be the first question if you are starting programming for the first time. Now, let's say there is a use case wherein there is a class of 100 students and you want to store the marks of each of those 100 students. Now, how will you do that? One of the way would be int Anshul marks. Okay. And similarly, we can have such 100 variable declarations for all the students, possibly Raj marks. There can be some other names as well, but in this way, you would have to do 100 initializations and you would have to do 100 such updates or anything that you want to do with all of these marks. Let's say you wanted to calculate the average marks of the class. Okay, you would need to write each of these variables separately, add them up, then divide it by 100 and then get the average. So why is arrays used? Arrays are used to store multiple values of the same data type. Okay, so in this case, you can just use something like this. This is the syntax of arrays. We can have the variable name for that array to be marks. This can be the declaration of an array of size 100. Now this is the data type. This is the variable name. Okay, var name. And this is the size of the array. Size meaning how many integer values it can hold. Okay, so now when you want to take in an input, you can just run a for loop if you want to and take in input from the user, like from the terminal. You can just type in the individual marks and you can store it in the marks array. Now we will talk about it, how you can add values to it, how you can update, how you can access and so on. But this is what the typical use of arrays is. We want to store multiple values of the same data type in this. Now, as I told earlier, this is how you declare. This is a declaration. Okay, we have given an example below as well. Now int arr4, which means that arr is short for array. Okay, this is one of the most common variable names that you can use for array. You will see that a lot typically when you start coding arrays for the first time. So int arr4, this means that now when this statement is executed, what will happen? Your machine will try to allocate 4 contiguous memory blocks for integers. So if you remember, an integer used to store 4 bytes. Okay, now let's assume these are the 4 bytes. 1 square is equivalent to 1 byte. Now when I say int arr4, it means that I need to have 4 contiguous memory blocks for integers. Okay, now that's the best part about arrays. These are contiguous in memory. The addresses are contiguous. So this is how it will try to allocate. I don't have space over here, so it might look like this is a separate line, but assume them to be in a serial order. So this is bit number 0. This will be bit number 8, 16, 32, and this will start from bit number 0. I think bit is not necessary because we usually do the computations in bytes. Okay, so let me just rub this and let us continue with bytes. So this is the 0th byte, first byte, second byte, third byte, and it will continue from the 4th byte. So if the address over here, let's say the address is ending at a particular byte. Okay, so let's say this is ending at the 3rd byte in our RAM. So this will start from the 4th byte itself. It is not that we allocate 0 to 3 bytes, like 0 to 0, 1, 2, 3 bytes to the first element of the array. We will allocate 15, 16, 17 and 18 bytes to the second element of the array and so on. It will always be in a contiguous order. Now you would ask, what if such a memory is not available? What if I have used all the memories so that there is no contiguous block of 16 bytes available with me? In this case, it's 16 bytes. I mean, in usual cases, you won't face this situation, but the machines are smart enough to rearrange the allocation of the memory, and they possibly might try to squeeze out the 16 bytes for you. In a real situation, this thing might not be possible. You would not encounter such a situation, but let's say if you are declaring something like this, int array, and let's say you are wanting to initialize 10 to the power 9 values. Okay, so this might be complicated because 10 to the power 9, how much this is? One integer is equal to 4 bytes. 4 bytes multiplied by 1 kilobyte, 1 megabyte and 1 gigabyte. Okay, so this is equivalent to 4 GB. Now this is very much possible that your system doesn't have contiguous 4 GB allocated with it. So you might want to reduce the size of the array in such situations. Now let me just get rid of this so that we can understand how the declaration, like we understood how the declaration is happening. Let's try to understand how the definitions, what all different ways the definitions can happen. So usually when we declared any variable for the first time, okay, we used to assign it either in the same statement or in another statement. So let's say this was v equal to 5. So this we used to call it initialization. And this we used to call it a declaration, and both of them combined was the definition of the variable. In arrays also it's the same thing. It can be integer, it can be character, it can be anything. First of all, it can be of any data type. It can be a float, it can be a double. Okay, this is not bubble, this is double, my bad. I am facing writer's block writing a D. Okay, so it can be any data type. Okay, first of all. So in initialization, what you can do is you can initialize one element of an array at one time. You can initialize the entire array at the same time as well. So arr of 0, arr 0 equal to 1 means that the first element of the array is equal to value 1. If you wanted to initialize the second value, it will be arr of 1 and so on. You can just initialize it to any value. It is important to note over here that the numbering in the array data structure starts from the index 0. The first element has the index 0 and so on. So if your array has size n, it will start from index 0 and go till n minus 1. So now some of the different types of definitions that we can have is in the first type over here. Now in the first type of a definition, we are allocating a memory equal to 4 integers and we are also assigning the values to it in the same statement. So you can use curly braces and separate the values by a comma and then assign any value that you wanted to for all those 4 elements. Now what would happen if I just assigned a couple of values and left it empty? Like for example, something like this. What if we did int array of 4 equal to this? Let me write it in a back, which is the fourth example in this case. If you notice, in fourth example also we are trying to do a similar thing. So what will happen is for the third and the fourth element, it will assign the default value, which is 0 over here. Now the fifth type of definition is a different one, because in this what your expectation would be, it will assign only the first value to be 0. But if you notice very carefully, since the value of the first element is 0 and we have not provided the remaining 3 initializations, it will automatically assign all the values to be 0. So explicitly and implicitly, what this fifth type of definition does is all the values of the arrays will become 0. So this is this helps with brevity. You can reduce the code that you are writing and assign all the values equal to 0 in one line itself, in one statement itself. If you look at the second type, it is a little bit different than what we have been doing till now. What we have been doing till now is we are explicitly mentioning what the size of the array is during its declaration itself. Okay, we are mentioning int array4 everywhere, wherever we have declared. But what if we don't mention it? Does it create an integer array of infinite size? No, that's not the case. So if you try to define it in this way, wherein we just write int array followed by an empty square bracket and then we write 1, 2, 3, 4. So this will implicitly try to convert it into an array of 4 elements. Now what if instead of 1, 2, 3, 4 we had 1 and 2 only? So in this case it will not automatically add or update the remaining 2 values which we are expecting it earlier to be 0. Okay, in this case what the compiler will do is it will create an array of only 2 elements, and once the size of an array is defined, you cannot change it. It is not possible that first we write int array4 and then we try to update the size of it. We will try it out in the code as well, just to check how we are doing it. And the third one is one of the most common one. Let's say we are getting the values which are supposed to be assigned to the array in a sequential order. We can write a for loop for n number of times if the size of the array is n, and then we can update the values of individual array elements to some particular value. It can be same value or we can take the inputs from the user as well. But let us just try to solve some of the doubts that we had while discussing the arrays. Let's say I just do a empty size declaration followed by 1, 2 in this. So according to me, what I feel is it will assign 2 integer elements to array. Okay, I think speaking array is a bit confusing. Let's say A only. In this case, A is an array. Okay, so in this case, the compiler will assign memory equivalent to 2 integers to the variable A, and those will be sequential in the memory. Now, for example, if I wanted to update, if I wanted A of 2, which is the third element of the array. Okay, remember zero-based indexing whenever you are doing any operations with arrays. Let's say I wanted to do something like this. Do you think this will compile? I think this will fail in compilation itself. Okay, it has compiled. So now I'm curious what the output for this is. Let us try to print in a for loop what the individual values are. So we'll initialize I equal to 0 and then we'll run the for loop for 3 times and we will try to increment the value of I every time the loop is running. Let us print A of I. Now let's try to compile it again and then let's run it. So if you notice, now this is interesting because even though I updated the a of 2 value, I updated a of 2 equal to 3, it is still printing 3 in my case. Now it should have been 1, 2 and 3, but instead it's printing 1, 2 and 2. So I think it's time to invoke one functionality of array, which prints the size of the array. Okay, so array name dot size, this is the syntax which is used to get the size of the array. So any type of a declaration, it can be an empty size declaration or it can have a declaration with a fixed size. Now if I try to do a dot size, this is the syntax of how I can get the size of the array which has been declared. It will return me the number of elements it contains. So let me just try to print this. Let me just try to add a string in front of it as well, some message, so that we know this is the size. Okay, so it throws me an error which says request for member size in A, which is of non-class type integer. Now I think it is time to invoke the special operator for sizes. So we will use the size of operator in this case. What size of does is, for example, if I did size of A in this case, or R, okay, if the name of the variable is R, integer, it will return me the total number of bytes which are occupied by this. So in this case, if there are 4 integers, then 4 cross 4, it should return me 16. So let us first try and print what size of A is in our case. Array size in bytes. Okay, this is not returning me the number of elements in this array. It is rather returning me the number of bytes occupied by this. My bad, this is A. Now let's try to execute it. It compiles and yeah, if you notice over here, it says array size in bytes is 8, which means that we have allocated only 2 elements to this, right? But somehow it is trying to get some unknown value for, so our output for size of A was 8 because we only declared it for 2 elements. If you notice in line 11th, we are only adding 2 elements to it. So whenever the compiler compiles it, it will only allocate memory for 2 integers, which is equivalent to 8 bytes in this case. And now this is coherent with the fact that when we are printing the array size in bytes, it is also returning 8 to us. But I think the compilers have become a bit smarter because, like in my college time, this used to throw me an indexing error that A of 2 doesn't exist. So somehow, let me also print the element value. Like what is the index? And value. Okay, so instead of 3 times, let me try to execute it 10 times and see what is actually happening behind the scenes in the code. So it still compiles, and when I try to run this code, okay, if you carefully notice that 2 was not equal to the last value that we have added in the previous initialization. Okay, when we perform this operation int A with an empty size 1, 2, and then we try to update the value of second element to 3. If I'm not wrong, it was 3. Yep. So now this 3 is not taken into consideration by our code, and if you notice, why is that the reason? We are printing 10 values, but we have only assigned 2 integer values to it. Rest all of the values are some gibberish garbage. So if you are not careful while trying to access some of the array values which you personally have not initialized or defined in your code, you can expect some unexpected things. I know this is an irony, but this is how, like, the compilers have become smart to not throw an error to you, but you also need to step up and understand where your code is not in sync with what you actually wanted to do. So if you are initializing only 2 elements and then you are trying to access the 10th element out of it, your code can behave in unexpected ways and it can lead to potentially damaging things as well. Alright, now this was a learning for all of us, including me, how efficient our compilers have become. They do the smart thing and they don't throw an error. But on the same hand, we should try to avoid such mistakes which are in our hindsight. Like we are not expecting them and somehow we missed out on that particular thing and it is leading to unexpected things. So what was the moral of this particular exercise that we did? That you should try to avoid initializations or declarations with empty sizes because they can then ultimately lead to unexpected things. Now let's say if I had initialized it earlier. Let's say if I initialized it for 3 values, which means that the third value would be equivalent to 0. Alright, let's try to execute the same code again. Now if you notice, till the third value, index 2, it is giving me the correct answer and has the value equivalent to 0, which it should have been. But it is still trying to throw gibberish values if I'm accessing more values than that after index 2. Okay, and if you carefully notice, the array size in bytes which is printed on the top has also updated from 8 to 12, which means that whatever initialization I was doing in line number 11, it leads me to a memory allocation equal to 3 integers. Now this is how in different ways you can initialize, declare and define your arrays. Now some of the properties of the arrays which we also have been talking since the beginning. The first one being the array elements are stored in a contiguous memory location. We will try to understand this in more detail when we talk about pointers and references at the end of this module. So this will become more clear then. Indexing of an array starts from 0. This should not be missed out. Let's say if you expect the indexing to start from 1 and go till n, you might face unexpected values for the last value, and what you expected to be the first value will in fact be the second value and so on. Like the consistency of the program is completely different. After an array is declared, its size remains constant throughout the program, which is true. Like initially, if we checked earlier, the array size that was allocated was 8 bytes. In the second modification, it was allocated for 12 bytes. But even though if we try to add more values to it, it's not changing the size of the array. Okay, now this is a very careful observation. Now the second part is, now this is the last part and very important part is it can have multiple dimensions. Now over here what we did was we had a single dimension array wherein if I had int a of size 4 and assign 1, 2, 3, 4 to it, this is what I would call a single dimension array. Now if I had 2 dimensions, which you can say x and y axis for example, so we can declare it in this way. For example, it's a 4 cross 2 grid. Okay. So now what this means is that we have 4 columns to it and there are 2 rows. Now indirectly this means there are 4 arrays of size 2. Let's try to check it out. What does this mean? Does this mean it has 4 arrays of size 2 or does it mean it has 2 arrays of size 4? Let's try to initialize both of them and let's try to see what happens actually. Now I will take a smaller example and try to check for 3 cross 2 array. Okay, so this means there are nested arrays within an array. So let's first try to check the hypothesis that there are 3 arrays of size 2 each, and if that fails we will check for the other option. Let us also try to print. For the timing, let's avoid printing what the individual elements are inside the array. Okay, let's first try to see if this compiles or not. This compiles and the output is array size in bytes is 24 because 3 cross 2 there are 6 elements, and what we are actually doing is we are allocating memory for 6 elements which are spread across 2 different dimensions. Now let's try to do the opposite thing and let's try to see if this again compiles or not. Maybe we are missing out on something. Okay, so here it says too many initializers for int 2, 3, which means that if you check the slide, Now what this declaration means, there should be two integer arrays, and inside each of these two arrays there should be an array of size 3, which means that we could have an initialization something like this. So this means there are two arrays overall, and in each of these arrays there are 3 elements. But if we move the definition to what we did in the code, this will lead to an error which says that what you are trying to do is actually initializing 3 arrays of size 2 each, wherein you should have done the opposite thing. Okay, so let's just try to correct this mistake, and let's try to see how we can access all of these values. So first of all, we realize that there are 3 arrays in this, and each of these has size 2. So we will have nested for loop for this to access both the dimensions. So now let's just print both the values over here instead of printing the index as well. Let's print the value of I first, followed by the value of j, and then we will follow it by the value of array of I comma j. Now we'll just add a space in between for visibility. And then how we are accessing it using the same way how we were trying to update the values. What array of I comma j will do is it will try to access in the first for loop, it will try to access a of 0 comma 0. Now inside the loop of I, there is another loop of j. So first for I equal to 0, there will be a loop from j equal to 0 to j equal to 1. And then we will update the value of I from 0 to 1, and then we will run the same for loop for j as well. Now let's try to see how the values are printed. The compilation is successful. Now if you see, this is how we initialize the elements. Now this is in coherence with what we had expected, and we also checked how we can access the values. So in this way we can have multiple dimensions. We had just 2 dimensions over here. We can have 3 dimensions as well, wherein inside an array there will be an array of arrays. Okay, it seems like Inception, wherein there is a dream within a dream within a dream and so on. And similarly in arrays also, like nested loops and nested conditions, if and else conditions, we had nested conditions. We can also have nested arrays. Okay. So now we already covered the part wherein we checked how we can access any element using the index. So for example, if I wanted to access the third element of the array, so I can just use a of 2. Okay. Now again, just trying to reiterate on this part, an array is 0 based index. So a of 2 will give me the value of the third element. So when I try to use this, let's say I want to add the value of the third element and the fourth element. So I can do something like this, and I can just print it out if I wanted to. I can assign it to some other variable as well. I can do anything I wanted to with these 2 values. So in this way you can access the value of any element in the array. In the same way that we accessed it, we can update it as well. If we want to update, like let's say it was initialized, array of 3, 2 was initialized to 1, 2, 3, 4 and 5, 6. Let's say I update the value to something else. Let's say I update the value of the first element to 100. I can just write this statement, and let's try to print the array once again. So I'll just name, print a statement new array so that we know the difference between the new array and the old array. So if you see in the new array, the value of, like in the first array, the value of the first element inside the first array is updated to 100, which initially was 1. Okay. So in this way, you can access the value of an array and you can also update it. And you can also run a for loop if you wanted to access or update any values. Like this is one of the most common ways. If you wanted to do something in a batch for all the elements inside the array, you could do that. Now there are some STL operations. Size was one of them, which I talked earlier, which gives us the size of the array in bytes. This is a wrong syntax. We can use, this is also wrong. We are not using STL operations over here, first of all. So if I wanted to get the size of an array, we will use size of operator. Size of A will return me the entire size occupied by A in bytes. For example, if I wanted to know how many elements are there inside the array, what I could do was divide it by the size of integer. Okay, so now size of A would be equivalent to 24 in this case, because we have a 2D array of 6 elements. So it will be 24 bytes overall, and size of integer is 4 bytes. So this will give me 6, which is the number of elements in this array. So let's try to check if this is true or not. Let me just update the statement that we were printing earlier for the size. So instead of bytes, we'll print the number of elements. So yes, it gives me the size of like whatever the number of elements are there inside the array, it gives me the same number that we were expecting. So in this way, you can use the size of operator to get the size of the array. And now moving on to a very important part of C++ programming language, which is strings. Now strings is a very important data type in C++ because for any textual processing, you would need a data type which can help you process text. So the data type for strings is as simple. I mean, string is the data type which we'll use. And let's say if I wanted to initialize something, it would be as simple as string s equals to hello world, for example. In the same way, like if it was an integer, what we did earlier was int a equal to 5. In the same way, we can define a string by having the data type, the variable name, and whatever value we wanted it to be assigned. Now there is another way in which a string can be initialized. String s, and in the round brackets, you can just add the string that you want to. Hello world in this case. And this will also do the same thing as our previous initialization was doing. So let's just try to do the same thing as I discussed, and let's try to see if this works or not. So what we'll do is we will first define the strings and then we'll try to print it as well. And let us comment this once again. So string s, let's say the string is hello world. Now let's define another string t, and we will use the same string for this hello world with t, just to be different. Now we can output the string in the same way that we were doing for other variables. We can print s, and same thing we can do for t as well. And let's try to see if the code compiles or not. For it does, and let's try to see the output. It does as expected. Now both the initialization works, both of them are equivalent. Like if you have a preference, for example, I prefer the initialization on line number 27th because it is similar to the other different types of initializations which I use for integers, arrays, and so on. So I would prefer that, but if you are more comfortable with the second type of initialization, feel free to go ahead with it. Now we also checked how you can output the strings in the same way as other data types, and in the same way you can take them as input as well. Let's try to take a string as input, and we can also print it later. String a, add a string. We can just ask the user to add a string. And we can then print it back to the user. Let's try to compile and run the code. add a string. Let me type my name. The string is Anshul. So in this way, you can take the input of the string. You can do the output of the string as well. Now, this was quite trivial because we were doing this for other data types as well, and this was very intuitive to us. Now, there are some other operations. One of the most frequent operation is string concatenation, which means we try to add both the strings. When I say add both the strings, this is not a mathematical addition. This means we try to merge both the strings. For example, string 1 was hello. Okay, S is equal to hello and T is equal to world. Now we can just do S plus T and then it will give me hello world. Now one thing to notice over here is it will not add spaces on its own when you are trying to add strings. So if you wanted to add a space, either you can explicitly tell that S plus some space plus T, or you can in one of the strings S or T. In S you can add the space after the string. In T you can add space before the string and so on. In that way you can explicitly try and add the string. Let's try to do the string concatenation. I will update the strings for hello and world for S and T, and we can try to replicate the same thing. So this should give us the expected output of hello world. And it does. So we can use the plus operator. For numbers, it will do the addition. For strings, it is doing concatenation. Now this is something which we call operator overloading, which we are going to talk in detail in the object-oriented programming module, which is a module 3 of this course. And we'll talk about that in detail, not for this module. So what we have covered is how strings are defined, how we can take strings as input and output, how we can do string concatenation. Now there are some other type of concatenations and some other operations that we can do on top of the string. Now first of all, it's important to realize what happens when I declare a string. Okay, when I define a string S equals to hello world, what happens? So string actually is an array of characters. So let's say hello world has 1, 2, 3, 4, 5 and 5, 10 and 12. It has 12 characters. Okay. So what the compiler will do is it will allocate the memory equivalent to 12 characters, which is 12 bytes, because one character was equivalent to 1 byte. So this memory will be allocated first. In the first byte, capital H will be stored. In the second byte, E will be stored. And in the same way, the 12th byte, exclamation mark will be stored. Okay. So this is an array of strings, and if you wanted to access one particular character, you can do it in the same way that we did for the arrays above. So let's say I wanted to print, which character can we print? We can print the second character, which will be index 1 of the string S. Okay, let's try to compile it. And then on running it, it prints E, which is the second character of hello. So it works as expected. And in the same way, you can update an individual character inside the string as well using the array syntax that we discussed earlier. So string element access and update is covered. If we wanted to update the string altogether, we do it in the same way as we did for other variables as well. So we could just do as is equal to hola instead. Okay. So let's just try to update it and then we can see what happens in the output. Compilation works, output also works. So if you notice, the addition or the concatenation of both the strings returns hola world, and the second element of the string S is O now. So in this way, you can update it as well as in the same way as we did for other variables as well, like other data types variable as well. Now, how can we concat strings? We checked the second way right now. These are two other ways in which you can concat the strings. The destination means that, like over here, we have two strings, destination and source. Now, when we try to do I would really recommend at this point that you try to pause the video and then execute the first type of concatenation and the third type of concatenation. When you do destination.append source, what it does is it updates the destination string to destination plus source. Okay, so the string is overwritten, the destination string is overwritten, and the source string remains as it was earlier. So we can try to copy this thing and try to see if it works as expected. String s.append t. Now let's try to print both the strings and we can see what has actually happened behind the scenes. So now let's try to compile the code first. Expected initializer token before dot. So it says expected initializer before dot token. Okay, let's check what the error was. All right, we didn't need to add the string in front of s.append because it's already been declared what the data type is. So we just need to write s.append t and it should give us the expected output. Now when we try to compile it, it does this time. And the output is for s, you can see like the string s got updated to hola world, whereas the string t remained as it was before. So if you want to keep one of the strings same and you want to update the other string, you can use this syntax. So we tried to check how the first type of concatenation happened. Let's try to see how strcat is happening. Now this is the third type of concatenation. Now in this case also destination is the s and source is t, so source won't change and the string in s should get updated to hola world. Okay, it says strcat was not declared in this scope and it also suggests us to add the particular header file for this. Now the compilers have become smarter than it were earlier. Earlier it just used to throw an error. Now it is also throwing me a suggestion that, hey, did you mean to include C string as well? Because it seems that strcat is present in that particular library. So let's try to follow that suggestion. Hash include C string. And let's try to compile the code again. Now it is throwing me an error again. It says cannot convert std string to char star. So this means that this might work on an array of characters, but this might not work on string. So let's try to initialize them to characters and let's see if this works or not. First of all, this can be let's just try to compile this once again. Okay, now there are more compilation errors. Okay, I think I should not have used the char pointer over here. I added it by mistake. Now it compiles, and if we try to check this, the output for S is hola world and T is world. So now we also learn another type in which we can initialize the strings, which is an array of characters. So strcat is applicable only on array of characters. Okay, and both of these types are applicable on strings. So this is also equivalent to string, but the implementation for that particular library expects it to be of a particular data type, to be of a particular explicit data type, which is char star. Okay, so this is also equivalent to a string. It will behave in the same way, but strcat library is meant to expect the source and destination string of type char star. Now you might be confused by what the star was, and I think it will be more clear when we talk about pointers in future in this module. Now that was it for strings. I mean, you can try out, there are some different operators for copy also. You can compare two strings in the same way as we compared the integers. S equal to T, you can just compare it and try it on your terminals, try it in your code if this works as expected or not. You can just try and do if s equal to t, you can print both are equal, else they are not equal. You can just try to execute that and see if it works as expected or not. But before doing that, you would want to, it will be valid only on the string data types. It might not be valid on char star data types. So you will want to change the data types of s and t to string. And then you can try the same thing again. So I'm not going to do it in this particular code. I'm leaving that as a friendly exercise for you to try and explore what all different provisions are there for string data type. Okay. Now moving on to a very important part, which is functions and scope. If you remember, all our C++ code had this int main. Okay. And we had this return 0 at the end of the code as well. Return 0 means end of the code, end of the execution of our code. Now int main, this is actually a function. Okay, this is a special type of function which tells the program, which tells the system that, hey, the name of this function is main and you need to start the execution from this function itself. Now what is a function? Function is just a block of code which you can use for modularity. For example, you can have a function to compute maximum of 2 integers. You can create a function to add 2 strings and return whatever the concatenated string was, and so on. You can have different types of functions. They can be trivial, they can be non-trivial as well. But the purpose of functions is to try and abstract some functionality out. Okay, you can just directly call the function and it will do the thing for you. For example, over here we used strcat function. Okay, we didn't know about functions, yet we used the function which took in 2 char star data types and tried to perform concatenation on top of it. We don't know how it was executed, what is there inside the function as well, but we know for sure that it is returning us a concatenated string. And that is the main power of functions. It abstracts those utilities out for us. So what is the normal signature or normal nomenclature for a function? There will be a return data type. Okay. What the output? There will be some output from the function, or there can be empty output as well. Let's say we just wanted to print something inside the function. So we can have an empty data type, which is void in this case, which we didn't cover in the first module. But you can use void if you don't want to return anything at all. And then instead of returning 0 or something, you can just write return followed by a semicolon. This will return the function whenever you want to. So now the first thing that you want to write in a function is the return data type, the data type of the output. Then it will be followed by a function name, and then you can have as input, you can have multiple variables. Okay, you can have, then you can do some processing on top of it, and at the end you can return whatever data type you wanted to. Let's say I want to create a function which adds 2 numbers. Okay, so what I will do is, it's an integer. First of all, what I want to do is addition for integers. For booleans, I will write a different function. If for doubles or floats, I would write a different function. So int add, I can just take in 2 integers, int a and int b. And then in the code, I can directly return a plus b. Okay, so whatever I am returning, this should be of data type integer. Let's say I return true. Then this will implicitly be converted to 1 because 1 is mapped to true and 0 is mapped to false, which we talked about earlier. So return data type, an important part. Then the function name, because that is how we are going to invoke it. Now what happens if I keep the return data type as integer and then don't return anything at all? I think it should throw some error. We can try and check it out as well. Then there will be some input. And this input can be of different data types. It can be a string, it can be boolean, it can be integers and so on. It can be anything. And then there is a code block within that function. So let's just try to write our first function. Let me get rid of all of these code which we had been commenting since a long time. Int add, and then instead of returning something, let's just not return it. Let's perform a computation for addition a plus b, and then let's keep our function as it is. Let's try to see if this compiles or not. to begin with, and then we can see how we can access the output. So first of all, it doesn't return anything, and it says no return statement in function returning non-void. First of all, this is a warning, this is not an error, so it still might get executed, but we need to resolve the error, which is A and B are not defined. So let's define them. Okay, let's try to execute it. It will execute, but nothing is returned. So it allows us to have an empty return type, but it also suggests that you should add something, you should return something so that the signature is fulfilled. So over here, we can just return C, which is the addition. We can also directly return A plus B as well. That is also completely normal. And let's print the output. So now it prints A plus B equal to 11. So this is what we had expected, and in this way you can create a function, you can define it on top of your int main, and then you can invoke it, like one function can be invoked from other function. Now if you remember, I also talked about there will be some class definitions, there will be some function definitions as well. So this is how a function definition looks like, but we cannot define it below the int main function. Why it is so? Because if you notice in line number 8, we are trying to call add A comma B, but at that moment, the compiler has not found the definition of that particular function. So it will say that no definition has found. Let's see what the compilation error is. So it says add was not declared in this scope. Okay. So this means that the order of the functions should be in such a way that the function which we are trying to invoke, there should be a definition and declaration of that function on top of it. Now let's try to declare it first. Let's try to, now this is the signature of declaration. We just mention what the name of the function is, and we just mention what the input data types are and what the output data types are, and this will run as expected. Now this has compiled, and this has also run as expected. So it is important for our declaration to be before the usage. We can define it later as well. So we understood how the declaration happens. We understood how the definition happens. So this is a declaration. And this is how we define it. Like definition is the entire function, how it should be executed, what should be executed, and so on. Now let's try to understand the scope of variables in this case. Okay. For example, I am adding a new variable C in add function. Can I access it outside the function or not? So it says C was not declared in this scope, which means that there are different scopes in our code. Let me just try to copy the code. There is another function int add over here. Now there would be some variables which are declared in int main function. There would be some variables which are declared in add function. So whenever the execution of this function ends, all the variables which were declared in the scope of this function will be thrown out. We will get rid of those variables. We will also free the memory. Okay, so it's like a stack. So for example, A and B were declared in main. Okay, so A equal to 5 is declared in main, B equal to 5, B equal to 6 is declared in main. And inside main we are calling add. So we are defining a function, we are defining a variable C, and then we are updating its value to 11. So this is the add function. Now when the execution of add function is over, when we return C, this is removed from our memory, and we only have access to the variables which were declared in the scope of the main function. Okay, so we need to be very cautious when we are trying to access some variables which are not actually defined in the scope of that particular function. Now, what if we wanted to access C? So this is where references and pointers come into role, and in the next section we will talk about that. Now, first of all, what are pointers? Pointers point to some memory, like pointers point to some address in our memory. Let's say we declared an integer a is equal to 5, and we also declared a pointer int star. This is the syntax, this is the data type of a pointer, which is equivalent to the address of a. Okay, so now ampersand shows us the address, like this is the symbol which we use to get the address of any variable. When we use ampersand a, this means we are trying to fetch the address of a in our memory. And when we are assigning it to p, it means that p points to that particular address in memory. To just make things simpler, let's say the address of a was x123. Okay, just giving some random name. So this was the address, x123 is the address, and it contains a is equal to 5. Okay, it will actually contain only 5. It will not contain a equals to. Now, when I execute this statement, it creates an element of type int star, which is a pointer. And pointer, if it's a 64-bit machine, okay, the addresses will be of size 8 bytes. If it's a 32-bit machine, the address will be of 4 bytes. So in my case, it's a 64-bit machine, so address will be of 8 bytes. So in this case, int star p, it will create a new variable. We can refer the first variable by a, we can refer the other variable by p. And in the variable p, we will store the address of a, which will be x123. Okay, and the size of x123 will be equivalent to 8 bytes since my machine is 64-bit. Now p will also be having some address. We can create such, like we can create a double pointer, we can create a triple pointer, and like such sort of crazy things can be done. But at this scope of this module, they are not important. So let's just try to execute this and see what is actually happening. Okay. Now I have tried to explain this part over here. Let's just try to replicate this in our code. Let me try to get rid of the add function call. Now int star p equals to address of a. First of all, we can't do int star p is equal to a, because then the data types won't match, because the data type of a is integer and data type of p is int star. So we need to get the address of a and then only we can assign it to p. Now we want to see what the, first of all, let's check the address of a, which is stored in p. So if we try to access this, this is some hexadecimal. I think this address is shown in hexadecimal, and it shows me the address of a. Now, if you carefully notice, p is equivalent to address of a. Let me try to add in the comment so that it's clear. P holds address of a. And when we want to try and get the value of a itself, we can use a star p, which is called dereferencing the pointer. When we dereference the pointer, we get access to the value which is stored at the address in p. Okay, it might sound a bit complicated, but star p is dereferencing. It accesses the value stored in the address of p. Like there is some address stored in p, it will try to look what the value is inside that address. Maybe like the comment is not so helpful, but I think like the statement that I gave would be useful to you. So let's just comment and run this code. So we see star p prints 5 for us, which is the value at the address stored in p. Now I can update the value of p by using the same thing, like star p is equivalent to updating, like a is equal to 4 and star p is equal to 4. Both of them are the same things. So we can update the value of p in that way. Now I talked about double pointers and called it a crazy thing. Why is that so? I would not try to do that. The reason is, let me just try to copy the same thing earlier, which I did earlier. Let's say the address is x123, it stores 5. Let's say the address of this is 456 and it stores x123 in it. Now when I do int star star double p, okay, now this should store the address to a pointer. So this should ideally be storing x 456 if we are assigning it to p. Okay, so if we are doing int double star double p equals to p ampersand of p, then it will store the address of p in the variable double p at some new address. But this can be a tricky thing because at this moment we get confused that double p is the address of what variable, and on dereferencing it what exactly we will get. And if I try to update the address, let's say I try to update, like if I try to dereference double p and try to update it to 5 for example, now what we actually did was we changed the address which was earlier there to 5. Now changing the address can have a lot of damaging implications. Let's say I tried to do double star of double p, which means that I'm trying to dereference whatever value is there at address 5. Now I actually don't know what is stored at address 5, because in my case I only had the knowledge what was stored in x123 and x456. Now this can be damaging, so I would not recommend you to try it at your systems, and I would certainly not do it in my system as well, unless you are confident and you know what is actually happening with the double pointers. Okay. So now, let's say we try to replicate this thing where int end of r is equal to a. So do you think this will create new memory? This is known as reference operator. Okay, this is like reference data type, you can call it. This is the reference data type. We will use ampersand for that. And what it does, it will just alias it. It will not create. For example, in int star p, what it did was it created a new value to store the address of a. But over here, it doesn't store a new value. It doesn't allocate a new, like it doesn't allocate new memory. It will earlier, like x123 was the address and it stored 5. We could access this by using a. And if we execute this statement, we can execute it by using both r and a, wherein the address of r would also be same as the address of a. Now this is known as reference, and if we try to execute the other part, it will create a new integer. It will allocate new memory to it, and both the addresses would be different. Now let's try to just replicate that thing and see if I'm lying or not, or if I know C++ properly or not. Now the first thing we will do is print address of a by using the ampersand operator. We'll try to do the same thing for r as well. And let's first see whether the address of both the variables are same or not. I hope I know C++ enough. Okay, if you notice, I didn't add a endl statement at the end for a new line, but both the addresses were same. So both the addresses are same, which means a and r are two variables. They just have different names, but they point to the same address and they contain the same values. This is same as me having some other nickname. Like for example, I don't have any nicknames, but for example, Virat Kohli has a nickname Chiku. Okay, so if someone calls him by Virat, if someone calls him by Kohli or Chiku, all of them point to the same person. Okay, so this is what reference data type also does. It doesn't create a new, like it doesn't create or allocate new memory to the variable. Whereas on the other hand, we know if it was instead of ampersand r, it would create a new address. Let's try to verify that. And if you notice, both the addresses are different. Now we just want to do one comparative study at the end to understand the difference between passing by value, passing by reference, and passing by pointer. Okay. So for that purpose, like when we pass in a function, when we pass something by value or reference or pointer, there are different implications of it. Let's create a function which takes in a input by value. We can take in an integer value itself. For example, this is f1, like just some random name. It will take an integer, and we just want to update the value of a to be a plus 20. let's say, and then we will return A. Okay, in the same way we will also pass by reference, and we will also pass a pointer, and we will name it F3 and F2. Here we are accepting a reference, and here we are accepting a pointer to A. So in the function 2, if you carefully notice, we are passing a reference, which means that it will not create a new copy of any integer. But in F1, when we are passing int A, okay, it will create a copy of that variable. It is similar to, let me break it down and write it as well. In F1, we are taking the value, taking the variable by value. So what it will do is, let's say we are calling F1 of 5, okay, F1 of some other variable. Let's say this was X in our int main function. So there will be some memory allocated to 5, and it will have some value. Let's say X was equal to 5. Now when I call F1 function, what it will do is, it will create a copy of the variable X. It will create and allocate memory to the variable A. It will create a copy of it and assign the same value. Now this is in F1 function, and this is in main function. Now when the execution of F1 function is complete, this will get rid. So if you are updating the value of A to be A plus 20, ideally you should not see the difference when you are returning the value in the main function. Okay, we'll just try to see this hypothesis. We'll just try to check what our output is. Okay, let's initialize A to 5, and let's get rid of all the other stuff. Let's also add some statements inside the functions to see how the values are updated. Now when we are passing by reference, let's print the addresses as well, so that you can realize what I was saying, that it allocates memory to the new variable whenever we are passing by value, and that does not happen whenever we are passing by reference or pointers. Pointer is basically we are passing the address of that particular variable to the function. So obviously it won't create a copy of that variable, but it will definitely create a copy of the pointer with it. But that pointer stores the same address, so that's completely fine. So don't forget to brush up your concepts before you appear for the next module. If you enjoyed this content and found it insightful, do give it a thumbs up and add in the comments whatever doubts that you have. Don't forget to subscribe to Scalar's YouTube channel and hit the bell icon so that you never miss out on the notification for such content. See you in the next module.